the universe could stop expanding remarkably soon, according to new research. In just 100 million years, the universe could start to shrink, new research suggests. I wonder what that would mean. And would it be a billiards type of a thing? Now, after nearly 13.8 billion years of non-stop expansion, the universe could soon grind to a standstill, then slowly start to contract. This is what new research published in the journal Proceedings of the National Academy of Science suggests. In the new paper, 3 scientists attempt to model the nature of dark energy. It's a mysterious force that seems to be causing the universe to expand ever faster, based on past observations of cosmic expansion. In the team's model, dark energy is not a constant force of nature, but an entity called quintessence, which can decay over time. The researchers found that even though the expansion of the universe has been accelerating for billions of years, the repellent force of dark energy may be weakening. According to their model, the acceleration of the universe could rapidly end within the next 65 million years. That's not a very large time scale in the cosmology of things. 65 million years. Then within 100 million years, the universe could stop expanding altogether, and instead it could enter an era of slow contraction that ends billions of years from now with the death or perhaps the rebirth of time and space. And all this could happen remarkably quickly, said study co-author Paul Steinhardt, director of the Princeton Center for Theoretical Science at Princeton University, New Jersey. He said, going back in time 65 million years ago, that's when the Chicxulub asteroid hit the Earth and eliminated the dinosaurs, Steinhardt said. On a cosmic scale, 65 million years is remarkably short. Nothing about this theory is controversial or implausible. Gary Hinshaw, professor of physics and astronomy at University of British Columbia, who was not involved in the study, said, however, because the model hinges on past observations of expansion alone, and because the present nature of dark energy in the universe is such a mystery, the predictions in this paper are currently impossible to test. For now, they can only remain theories. Energy of the void. Since the 1990s, scientists have understood that the expansion of the universe is speeding up. The space between galaxies is widening faster now than it was billions of years ago. Scientists name the mysterious source of this acceleration dark energy, an invisible entity that seems to work contrary to gravity, pushing the universe's most massive objects farther apart rather than drawing them together. Though dark energy makes it approximately 70% of the total mass energy of the universe, its properties remain a total mystery. Again, this is only a theory. A popular theory introduced by Albert Einstein is that dark energy is a cosmological constant, an unchanging form of energy that's woven into the fabric of space-time. If that's the case, and the force exerted by dark energy can never change, then the universe should continue expanding and accelerating forever. However, a competing theory suggests that dark energy does not need to be constant in order to fit with observations of past cosmic expansion. Rather, dark energy may be something called quintessence. It's a dynamic field that changes over time. Steinhardt was one of 3 scientists who introduced the idea in a 1998 paper in the journal Physical Review Letters. Unlike the cosmological constant, quintessence can be either repulsive or attractive, depending on the ratio of its kinetic and potential energy at a given time. Over the last 14 billion years, quintessence was repulsive. For most of that period, though, it contributed insignificantly to the expansion of the universe compared to radiation and matter, Steinhardt said. That changed about 5 billion years ago when quintessence became the dominant component and its gravitational repulsion effect caused the expansion of the universe to speed up. Steinhardt said, the question we're raising in this paper is, does this acceleration have to last forever? And if not, what are the alternatives and how soon could things change? The death of dark energy. In their study, Steinhardt and his colleagues, Anna Ijus of New York University and Cosmin Andre of Princeton, predicted how the properties of quintessence could change over the next several billion years. To do this, the team created a physical model of quintessence showing its repellent and attractive power over time to fit with past observations of the universe's expansion. Once the team's model could reliably reproduce the universe's expansion history, they extended their predictions into the future. To their surprise, dark energy in their model cannot decay with time, Hinshaw said. Its strength can weaken, and if it does so in a certain way, then eventually the anti-gravitational property of dark energy goes away and it transitions back into something that's more like ordinary matter, he said. According to the team's model, the repellent force of dark energy could be in the midst of a rapid decline that potentially began billions of years ago. In this scenario, the accelerated expansion of the universe is already slowing down today. Soon, perhaps within about 65 million years, that acceleration could stop altogether, and then within as few as 100 million years from now, dark energy could become attractive, causing the entire universe to start contracting. In other words, after nearly 14 billion years of growth, space could start to shrink. And this would be a very special kind of contraction that we call slow contraction, Steinhardt said. Instead of expanding, space contracts very, very slowly. Initially, the contraction of the universe would also be so slow that any hypothetical human still alive on Earth would not even notice a change, Steinhardt said. According to the team's model, it would take a few billion years of slow contraction for the universe to reach about half the size it is today. A billion years. The end of the universe? From there, one of two things could happen. Steinhardt says either the universe contracts until it collapses in on itself in a big crunch, ending space-time as we know it, or the universe contracts just enough to return to a small state similar to its original condition, and another big bang or big bounce occurs, creating a new universe from the ashes of the old one. In that second scenario, which Steinhardt and other colleagues described in the 2019 paper, the universe follows a cyclical pattern of expansion and contraction, crunches and bounces that constantly collapse and remake it. If that's true, then our current universe may not be the first or only universe, but just the latest in an infinite series of universes that have expanded and contracted before ours. And it all hinges on the changeable nature of dark energy, he said. How plausible is all this? Hinshaw said the new paper's interpretation of quintessence is a perfectly reasonable supposition for what the dark energy is, because all of our observations of cosmic expansion come from objects that are millions to billions of light years away from our Earth. Current data can only inform scientists about the universe past and not its present or future, he said. So the universe could very well be barreling towards a crunch, and we'd have no way of knowing until long after the contraction phase began. I think it really just boils down to how compelling do you find this theory to be, and more importantly, how testable do you find it to be, Hinshaw said. Unfortunately, there's no good way to test whether quintessence is real or whether cosmic expansion has started to slow. For now, it's just a matter of fitting the theory with past observations, and the authors do that capably in their new paper. Whatever the future of endless growth or rapid decay waits our universe, only time will tell. This is by Brandon Spector on Live Science. Again, this is only a theory. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.